So we're going to be doing exponents and radicals. So if a b is a real number and n is a natural number, we're going to leave n as a natural number, meaning that it is an integer and positive and non-zero. So that means b to the n is b times b times b times b n times. And so that means we'll show it here in detail. The expression is called an exponential expression. So this expression here, where b is the base and n is the exponent. So we say b is the base and n is the exponent. If a is 0, we define this equal to 1. There's a really good reason for that. It's because 1 is the multiplicative invert or multiplicative identity element for the ring. Basically, 1 is if I multiply by 1 times anything, I get back the same thing. So 1 times a gives me a. And so if I have 0, so if I have 0 3's and times 1 5, that's going to just give me 5 because this should turn into 1. Okay, so that's the reason a to the 0 is defined as 1. Is that way, if I have 0 of a number, when I multiply it by something, I should get back the same thing. That's why. If a is negative, we just take 1 over that. So we'll make it into a fraction. So let's actually show you how this is done and go over some examples. Let me open up the all right. So here if we have 5 times 2, it'll be 5 times 5, which of course we multiply that out, it's 20. Here if we have 0 squared, well, this is technically 0 times 0, which is equal to 0. So notice that a to the 0 is equal to 1, 0 to the 0 is this. You cannot do 0 to the 0 currently. Just ignore that one for now. Here, if I have negative 3 squared, I'll have minus 3 times minus 3 times minus, or not squared, but cubed. So 2 is, we say squared. If it's 3, we can say it's cubed. Anything other than that, we just say what the exponent is, negative 3 raised to the third power. So here, we'll calculate this across. This is minus 27. 6 raised to 0 power is 0 sixes, so that's 1, and reason explained up here. 3 to the minus 2 power is equal to 1 over 3 squared, which we can simplify to 1 over 9. And then here, if I have negative 4 to the 4th power, this is minus 4 times minus 4 times minus, just do it this way. Oops. That make it a little bit more clear what's going on. So 4 times 4 times 4 times 4 is 256. 2, 5, 6. And then negative, 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 negative. So there's 4 negatives here. So 4 is an even number, so it's a positive number. Please be very clear that negative 4 to the 4th power is different than the negation of 4 to the 4th power. And the reason this is true is because in this, negation does not happen in order of operation until after the exponentiation. And so here we'd exponent, so this would be 4 to the 4th, so this would be minus 256. So this and this are not the same. So be kind of careful about that. The reason, and so later on, you're going to see every time I plug in a value for like in a quadratic or like x squared or something, I always plug in values in parentheses to prevent errors like this. And it also, not only does it make it mathematically correct, it also makes it functionally more, if I can say this correctly, it makes it easier not to make mistakes. And it makes you be very careful about your minus sign. So when I plug in stuff, I always use the parentheses, and you'll see why that is later. All right, let's go ahead and grab up here. Scientific notation is A is said to be in scientific notation if A is equal to B to the 10 to the nth power, where B is somewhere between 1 and 10, not including 10, of course, right? Because once it's 10, you just move back down. And N is an integer. And so here when we write stuff in scientific notation, you're to write, you take this, and what I do is I just count how many times I bounce it. So 1, 2, 3, 4. So I move it over 4 times. So it would be 10 to the 4th. Oops, I forgot the rest of the letter numbers. 8 times 10 to the 4th. Here, if I go backwards, it'd be 1, 2, 3, 5, 6. Remember, you have to make this a single digit. So it'd be 3.4 times 10 to the minus 6. And here, if I move this over, it'd be 1, 2, 3, 4, 5, 6. Yeah. That'd be 10 times 1, 2, 3, 4, 5, 6, 5 times 10 to the 6. One real quick question, note for you engineers. If I have 1.000 times 10 to the 4th, is this equivalent to, so my question is here, are these two the same when it comes to scientific notation? Are these two the same? Just kind of put it in chat if you think yes, if you think no, and why. See if anyone's awake. Yes, they're the same. Yes, but they have different statistics. Well, I think I like that answer the best. Mathematically, they're the same. Scientifically, they're not. So in math world, these are equivalent, right? Because this is the same as this. In the scientific world, you would say this is different from this because here I can say I know it's 1 with about an accuracy of 3 decimal places for significant figures, and here I know it's a 1 with no accuracy really labeled to it. And so when you play the little significant figure game, so when I asked this in a math class, yes is the correct answer, right? These are the same. But in your science classes, they may differ. So just to give you a warning, engineering, but I think in engineering, you guys play with significant figures a lot if you want to know how accurate your measurements are. So, all right. I'll take a drink after the end of each page. That way it gives you time to finish writing. Also keeps me hydrated. I can go on hashtag HydraHomies or whatever it is on Reddit. Joking. I don't subscribe to that one. It'd be fun though, right? All right. So let's look at properties. So a to the m. So a to the n plus a to the m, you just add up the exponents, right? So here we're just adding the exponents. And the reason is, let me kind of be very kind of pedantic about this. This is 3 times 3 times 3 times 3. This right here is 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. Yeah, it's 7. And so if you count them all up, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so the reason you can just add up exponents is it's how many threes do you have? Here I have 4 threes, here I have 7 threes, add them up, you'll have 11 threes together, multiplied, right? Same thing happens here. Here, if I have 5 to the 6, I can cancel out 5 of the, I don't know if I'll do all of them. Here, I'll do this one. Here, if I have 3 squared times 4, so I'll have 3 times 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 3. So the reason we multiply them is I have 4 sets of 2. So add them all up. You can distribute in. This is a very useful property. You can do that for this. You can do it in parentheses. And if you do a negative, you just flip them upside down. So here, if I have 3 over 5, I can, to the negative 7th power, I can flip it to this. So one thing you kind of need to get kind of careful, better at is kind of simplifying these significant figures. And so here, for this, we just add it up, and this will be y to the, I can add in my head, 12. Here, what would the answer to be? What's the answer to be? See if someone put that in chat. What's the answer to be? I have c to the 4th and negative 2. Yeah, so c to the negative 8. So that's correct. So here we just multiply this and we get negative 8. And if I wanted to simplify it like this, I don't know if this is any simpler than this. Honestly, I don't. I think these are equally simplified. Here I just got rid of negative. Here that's fine. Either answer here is good. All right. Please note when you'll type in a caret for the computers in order to signify exponent. Usually when it comes to computer writing and coding, caret means, so caret 7 would be how I'd write this, is I put the caret symbol, and if I want a subscript, I usually just do R7. When I actually type in all this, I actually type in R's caret 7 and it recognizes it and rewrites it as this. So this is just how you code it into a computer, superscript and a subscript. And superscripts in math mean exponents. So let's do this. So here we put this on both top and bottom. So let's be 2 to the 3rd, x to the 3rd, and then you can simplify if you want at x. Here, I can stuff the exponent into each. So we'll do that. So it'll be 3 to the 3rd. It'll be a squared to the 3rd, and then b to the 3rd. So this becomes 27. A squared to the 3rd is multiplication, so this becomes a to the 6th. And this becomes b to the 3rd. Okay. Any questions on this one? This one might get you a little bit confused. Here we have r to the 7th over this, so we can just write this as r to the minus 3, which equals r to the 4th. And if you couldn't see that, you can actually just write out the r. So 1, 2, 3, 4, 5, 6, 7 over 2, 3. So here if I cross off 3 of the r's, I'm just left with r to the 4th up top. I guess my r's look a little bit like these. Here, we have this big monstrosity. And so what I like to do is I like to simplify in steps. So here, I'm just going to put in the exponents. And this will be multiplied by x to the 3rd. 3 times 3 would be y to the 9. C to the 3rd. Then from here, I like to simplify from what I got. So here I have y squared and y to the 2nd. So I'm going to cross this off and this makes that a 7. And we'll add that up. So this will be x to the 5th, y to the 7th over z to the 3rd. Any questions on this page whatsoever on how to handle exponents and deal with things like that? Okay, so let's go on to the next page. All right, definition of radical. So a, square root of a, is is equal to b, that means b squared is equal to a, where b is greater than 0. And then you can have nth roots. So this is technically, so a squared is, this is technically a second root, right? So I could have third roots, fourth roots. That means b to the n equals a. And if b if n is even, so if this is an even number, this a has to be positive and the b has to be positive. If a is odd, you don't need that. You just don't. You can have a here be negative and you can have b be negative. So if you're going to simplify each expression, so the square root of 16 is 4. Why? Because 4 squared is equal to 16. Here, the fourth root, and we call this the fourth root of 4 is equal to 2 because 2 to the fourth is equal to 16. And so how do you figure this out? What you need to figure out is something raised to the third power, so let's do this one, is equal to minus 8. Well, something raised to the third power is equal to minus 8. I know whatever the something is better be negative, right? Something better be negative because I need to get a negative out of it. So negative times negative times negative will give me negative 8. So what do I need to get here? So here, you can prime factorize 8. 8 prime factors is 4 and 2, or 2 times 2 times 2. And that's perfect because that's exactly what we need. We get 2 and 2 and 2. So negative 2 times negative 2 times negative 2 will give us negative 8. Now you guys are going to go be engineers. Yeah, you guys got it right. You guys are going to go be engineers. So what are you going to do? Type this in a calculator. And so let me actually open up our official calculator for the first time. All right, our official calculator. Oh, this is Wolfram Alpha. And so here, pretty sure if I want to take, so in order to type the square root of 16, we do it like this. And so you just type in SQRT 16. And this is pretty common against most of these computer algebra systems. And so when you, this is a, they call these a computer algebra system, or CAS or CAS for short. These are just ways of inputting stuff. And so it's important to know how to input things into a computer. I get students in my higher level engineering classes who have no clue how to do anything in a computer. And it kind of scares me. It's like, these are engineers. They're going to do everything in a computer. And so this is how you do that. So let's say I want to find the fourth root. So in most programs, it's the same. You just put bracket for bracket. And they have, you know, where it looks, did I get the right result in here? So here, if I wanted to find the cubic root of minus 8, here we go. Get the cubic root of minus 8. So here's the real root. There are other roots here. There are other roots, but please, please, please do not worry about them for now, okay? So that's the one thing, if you type stuff in the computer, you're going to get really fancy things like, right? And so you can get, there's 3 roots here. This is the root we care about, okay? So just be careful when you type stuff into the computer, you're going to get a bunch of, so here's technically the roots. If you take a complex analysis class, you'll understand the roots of unity and work really hard with that. The rest we don't have to worry too much about right now, okay? I think you might actually see this in calculus. But they don't really go that deep into. So this is just something to be careful of when you're dealing with higher end roots, especially with negative numbers, you're going to get complex stuff. We're not going to deal with that right away. but we might deal with some of it later. Okay. So be careful when you type stuff into the computer. Sometimes it's going to give you a bunch of garbage. You're like, oh, I don't know what to do with that. You have to be able to discern, oh, I just want the real root of this. Okay. So this is I want you to get used to saying things in calculators. That way you can kind of know what's going on. Because if you guys just type that in and saw all those weird answers, you type in really weird answers in the Wolfram Alpha and get wrong things like, oh, I don't understand what happened. So it is good to know how to do it by hand. So let's do some laws of radical things real quick. So let me kind of go through these, simplify each expression. If we can go do this. And so this is here to help you get comfortable with everything that could happen here. So let's do this. So here, notice that if I write a to the 1 over n, that's the same thing as the nth root of a. Same for all radicals. You can do it this way. It doesn't matter if you have the m on the outside or the inside, it ends up being functionally equivalent. I guess it's better to do it this way for a particular reason, which I'll leave out. So the nth root of a to the n is a, if n is odd, and it's the absolute value of a, if n is even. And the reason is here, if I took -2 to the 4th, and I took the 4th root to it, well, -2 to the 4th is 2, 4, 8, 16. So this is 16, right? And the 4th root of 16 is 2. So it ends up being the absolute value of that number. So here, a to the half is the same thing as the square root of 9 to the half. It's the same thing as square root of 9, which is just 3. 8 to the 2/3. Well, how do I do this? Well, I can just take 8. I can take the cubic root of 8. Oops, from my cube right here, and then square it. Well, the cubic root of 8 is 2. And then if I square 2, I get 4. If you do it the other way, you should get the same answer. You can get 8 squared would be 64, and the cubic root of 64 is 4. Yeah, so it works out the same. But go ahead and do it this way, just for safety reasons. All right, let's be very, very careful what's happening here. This I wanted you to be very careful with. This, so -3 to the 3rd power is, I guess this one, you don't have to be that careful. These are the same because of the negative root, and then according to our rule, it's -3. But if I have the parentheses, I could just jump straight to it, but I don't have the parentheses. Here, if I want to change this, here I'm going to write x to the 5/4. So here I just want to show you that here, if I have a radical, I can write it as a fraction, and if I have fractions, here if I have fractions, I can write them as radicals. Okay. Here, notice when we have radicals, if I have the same integer value here, I can add them up. And so this is 5 square root 3. It's something you can do. This is very useful. And you're gonna just treat these like a variable. I'm gonna hold off on that for a second. Let's do this one. So here, if I have multiple things, I can take the 4th root of what's on the inside. Now, why can I do this? Let me make it very clear why I can do this. I can write this as 81 x to the 4th and z to the 8 to the 1/4 power. Now here is the same as here, right? So I can do this distribution. So I can distribute this into each. So I can actually do 4th 81. This only works if it's a single term. If there's like another term, like if I have the square root of 2 plus 5, I cannot bring in the square into the 2 and to the 5. That's not allowed. It's all one term, aka there's no plus or minus signs. You can do this. All right, so the fourth root of 81 is 3. Here we have this situation, and where a is even, so I can write this as the square root of x. Here, this will be z squared, since these two will, the 4, it's easier to see as z to the 8/4. You can simplify this fraction, even if it is an exponential, to z squared. Now, do I need to take the absolute value here? And the answer is, yeah, I could. This wouldn't be incorrect. However, since the square is there, you already will be doing it. Negates the necessity of adding an absolute value, if that makes sense. So here, if I see this, you can always try to simplify these. So remember here, I can write 32 as 16 times 2 plus, here I can write it as 100 times 2. And then here, I can go ahead and rewrite this as the square root of 16 times the square root of 2 times the square root of 100 times the square root of 2. Well, the square root of 16 is 4 square root 2 plus square root of 100 is 10 square root 2. And then I can simplify this to be 14 square root of 2. Okay. So if they're different, sometimes you can pull out what they call out pulling out a perfect square. So 16 and 100. You may have seen this done differently, but it's just kind of using the tools I've given you. This is how you would do it. All right, so let's deal with let's do I. So here, 27 to the negative third power. So I can write this as 1 over 27 to the third power, which I can write as 1 over, oops, the cubic root of 27. And the cubic root of 27, of course, is 3. So this will be 1 over 3. Okay. So when you see something kind of complicated, take it a step at a time. Deal with the negative, drop it below. Deal with the fraction, make it a cubic root. Then compute the cubic root and get the answer. Okay, so take these a step at a time, even though it doesn't look like there are multiple steps here. There are. All right, so let's see. How would I deal with this? How would I simplify this? Well, let's just write everything as exponents. Is everyone okay with this? So here I've written square root of x as x to the half. Here I've written this square root as to the half. Now I'm just going to distribute in the half. So here I have 1/2 times 1/4. And now I'll just add them up. 1/2 plus 1/4 is equal to, my computer please. Hello, computer. No, my thing just died. I'll have to plug it in for a second. Hello. Are you guys there? Or did my whole thing freeze up?
We're still here.
Oh, you're still there? Oh, good. Just my Photoshop froze. Photoshop. No, we're at the last one. Anyways, this becomes x to the 3/4. I would show it to you, but my Photoshop crashed. Photoshop, why'd you crash? Hello. Let me, oops. Let me force clear real quick and restart it. You. Bye-bye. Oh. Let me just show you my answer key real quick for those who are still writing stuff down. Okay, so here's the answer key real quick for those who are still writing stuff down.